What is wrong with ExpressLRS? Why ELRS version 2 cannot work with device on ELRS version 3? Why can't I flash SPI ELRS with ExpressLRS configurator or can't use Wi-Fi mode? What is the difference between wide and hybrid modes, and why AUX 1 always have only maximum or minimum values even if I use it for 3-position switch? Finally, why ELRS can't be as simple as Crossfire? If you are looking answer for any of these or other tricky questions, then bingo! You are in correct place and looking correct video. I will give you answer on all these questions, and actually summarizing all of this aspect has a background, and this background is hidden somewhere inside how ELRS works, inside its principles and algorithms. So this is what I will speak today about. And briefly, very briefly, how ELRS works, this how. So you thought I'm joking? No, I'm serious, and later I will tell you why. And as you probably guessed, today I will speak about ExpressLRS, about how it is working under the hood. And you probably know that there are lots of dozens of instructions in Google, YouTube about how to configure one or another ExpressLRS device, but there is almost no information about its principles, its algorithms, and how does it work inside. So I have made a kind of research and will try to describe this for you. And please, if you find any mistakes in my speech, or if you know the better, and I'm sure some of you really knows it much better, please describe it in comments. It's very valuable for me to understand how. And if you are still interested, so please set the like, subscribe, and let's go deeper. So ExpressLRS is a protocol that used to control your drone or your plane or whatever your remote control device. And before answering the question how does it work, let's answer a question why do we need a new protocol when we already have dozens of other protocols. And let's check what does developers of this protocol tells. Let's Google ExpressLRS and we open the main page. So what do we have? Okay, we've got a control link. You already know that the drone has two types of link. First, it's for video transmission, and the second, it's for control. And the video transmission used very big amount of data. You know that the films on your PC actually takes a lot of space. At the same time, the control data, it's like a text file, which is very, very small, especially comparing to the video files. So please keep it in mind. I will show later how it limits us. Next, it should be the best. Just the best. We'll check if it is. It should be completely open. What does it mean? It means that all the source code, all the schematics, PCBs, it's open. You can take it, you can use it, you should not pay anyone, you should not get any license, and you can go to the GitHub. So Google, okay, GitHub, ExpressLRS, and here it is. It is a source code, so you can register here and you can modify it. For sure, if you can understand what is written up here. Next, it should be highly refresh ratio. So yeah, The community of ExpressLRS is rather wide and it grows very fast. We've got lots of new and new versions. By the way, it's another one tricky info, and later I will tell you something about these versions. Next, it should work on maximum achievable range. So you should be able to fly as far as you can. And it should be very low latency, so when you press the button, it means that your drone should work simultaneously. Not press and wait and work, it should work just now. And it should use open radio links, so 9 MHz, 900 MHz and 2.4 GHz. It's just open system, so you don't have to have any license or whatever to make a device that works on these frequencies. And another consequence of open stuff, it is cheap. For example, there is a protocol like TBS, Crossfire or Tracer, which works same far, same good, same fast, but it's 2 times more expensive. So here is. And to answer the question why, let's imagine that old protocol, it's like a person who just trying to cry and tell drone, okay, you go left or now go forward and do what I say. And drone hears to it and executes the command. But if you stay far away from the drone, just imagine that you are staying at the one part of the field and the drone is on another part of the field. And you are crying to drone, but drone can hear that you are crying something, but he cannot understand what word actually you tell. Or if you work on some factory, you are trying to cry, but there are so lots of noise around that the person next to you even cannot hear you very well. So we should solve this problem. And the fact that most of the question already has an answers. And this is the same situation with ExpressLRS. So do you know what is Alpian Doodle? Or Doodle? I don't know how to pronounce it. It's a kind of the songs. You can imagine that men far away in the mountains are just crying. And it's not just a kind of art, or it's not just a kind of music. There is something behind of it. This person who live in the mountains, historically they didn't have any phones or radios, and they had to communicate. So you see the similar situation. They was looking for communication methods, and they had the similar problems, and they understood that the different song, different mediation can be assigned with a different message. And when one man in the mountains are singing this song, another man far away, he may not hear the exact words, but he understands this rhythm, he understands the sequence of the high-low voices, and he understands, okay, this sequence means that this message. And they've got some agreement that one message, one thing, another message, another thing. The same works this protocol. And we've got next step. Let's check ExpressLRS. It is Express Long Range System, and it is based on the LoRa protocol. It is a hardware protocol, and it is absolutely what doodles do. So let's check what is LoRa. So we've got 2 terms, modulation and LoRa. And modulation is just an agreement how we represent our signal in physics. What frequency do we use, what hardware do we use, and the most simple example of modulation is amplitude. Let's say we've got a signal. The signal is a wave, radio wave, And we can say the bigger wave will mean the joystick up, and the smaller wave means joystick down. And the higher we raise the joystick, the higher wave we will have. It's very simple in hardware, but it got the negative aspect. When we go away from our transmitter, the level of the signal will reduce, and we will never know if this level, when signal reduce, if it is because we are far away from transmitter or because we have moved the stick down. So we cannot use this example. Another one example is amplitude. So we can agree that the one position of stick means one frequency and another position of stick means another frequency. And when we move the stick, we just change the frequency. And when we go away from the transmitter, yes, we will have the lower value of the signal, but the frequency will remain unchangeable. So we will know definite position of the stick. By the way, the Fly Sky protocol uses approximately similar modulation. But it's still not ideal. And it's not so good with the noise and so on, so we still have to find out any new protocol. And here we've got LoRa. LoRa, let's read. It is a physical proprietary radio communication, and it uses spread spectrum modulation chirp spread spectrum. There are lots of many clever words, and actually if you want to know very detailedly, I will leave the link to the very good video that was proposed for me by developers of ExpressLRS, but let's try to understand it in more simplified way. Just imagine the simple wave that has the simple frequency. And let's imagine it in a sound. It is this one. And now let's imagine the wave, the signal that changes the frequency. Okay, and now let's duplicate these pieces, and what we've got. Okay, and now when we want to determine which of these piece is corresponding which message, we can split each triangle and split and mix up, rotate these positions. So we've got this. And let's compare. Now you can see why have I used that example in the beginning of the video. So this is LoRa. But LoRa it's only part of ExpressLRS. And another part is actually what data do we transmit, do we send and receive. So let's go and check the data format. But before going to the deep inside of the data format, we should check what speed is capable LoRa. Because, for example, if you are sitting at home and you got gigabit internet, it doesn't matter for you to download the big movie or just to read some article at internet like Facebook or even Wikipedia. But if you go far away in the history to dial-up time, then you probably limited with the speed, and you cannot even download file, you cannot even download some website because it will take more time. So let's check what speed is providing LoRa. And I have googled a lot, and there are lots of formulas, graphics and so on. And I have finally found this article. LoRa developers, SM Tech, LoRa 2.4 GHz and So we have speed. Speed is variable. It can be 1 and 2 kilobits per second or 63 kilobits per second. By the way, typical dial-up speed it's about 50 kilobits per second. So we've got like dial-up. So it is very low speed, and we are really limited with the amount of data we are transmitting. And because this difference is about 60 times different, what it depends on? And it depends on some coefficient. It's SF, it is spreading factor. And if we get back to the LoRa characteristics, so we can see that the spreading factor, it is the settings that describe the form and the amount of these triangles. And we can choose if we want to send bigger packets that will be more stable, will be capable to catch this packet on the far distance, but not a lot of these packets per second. Or we can use smaller packets, we can shoot it very frequently, but it will work not as far away as we would like it to be. So it is just about a balance. Long distance, lower speed, shorter distance, faster speed. And if we go to ExpressLRS configuration in our remote, we can see the packet rate, which varies from 50 packets per second to 1000, and we will speak about it a little later. And correspondingly, if you go to the ExpressLRS settings in your remote controller, you will see packet rate. One packet is just one message from your remote to your drone that contains all information about sticks. And the more packets per second you send to the drone, the more accurate will be control. As you can see, packet rate can be changed from 50 Hz, 50 updates per second, to 1000 updates per second. I will tell you about the packet itself in a few minutes, but now please see the digit near these packet rates. It is minus something decibels. What it means? It is the actual sensitivity. What signal level may it catch at which packet rate? As you can see from our previous LoRa experience, we can make longer distance, but only if we reduce the speed. And here you can see also, if you open the page on ExpressLRS, you will see which frequency relates to which sensitivity. Sensitivity is measured in decibels. I will not go into what does it mean, just keep in mind that it is some negative value, and the deeper it goes to negative, the lower signal strength is. And as you can see, at 50 Hz we can keep one signal, minus 115. At 500 Hz it's minus 105. And 1000 it's minus 104. So you can see this back relationship. But probably you ask, what does give me these decibels? Please give me the real range. How far can I fly? And ExpressLRS guys has the answer for you. Here is the page, long range competition, and you can see the different results. At which power, at which frequency, packet rate, how far have they fly away. And also you can see the proof of this link to the video recording of DVR. So now when we know this relationship, let's speak more detailedly about the packet itself and what it means for us. So we've checked the packet rate, what does it affect to, and we've got some base knowledge about physics, and we came to the question of packet format. And answering the question, why do I need the packet format knowledge and what does it affect too, let me show you one experiment. An experiment is as following. I took all channels and configured to transmit value of throttle stick. So all should transmit these accurate, slowly changing values. And let's check. And as you can see, not all channels actually get the values that we expect. Only sticks and channels up to aux 8 has correct value because the stick is down, and the rest aux 9, 10, 11, 12 just has some strange values. Okay, let's try move. Okay, what do we see? And we see that accurately changing, corresponding to the stick, only the stick's channels. First four. Aux 1 jumps from 0 to maximum, and channel 1 or 2 to 8 so switch with some steps, so not so accurate, and you can see that they change not immediately, but I will tell you a bit later about it, more details. Okay, so we can see that it behaves some strange. And now let's change the configuration a bit. We go to ELRS menu and let's switch this hybrid to white. And go to check again. What we see, okay, we've got connection. So now, as you can see, channel 2 to aux 9 change more accurate, but aux 1 still switch from minimum to maximum, and the aux 2 to aux 8 change not simultaneously, but with some delay between each other. Okay, let's now check why all this is going on and what stays behind of this behavior. And the reason that stays behind of this messy behavior, it's old conflict of speed and amount of data. Which one we can pay more attention to? And we already know that the packet rate, the speed, might be maximum 1000 packets per second. So let's check what the amount of data can we have. And I have googled a bit more and have found out from somewhere deep of internet that LoRa speed might be up to this value. I'm not sure if it is correct because it's difficult to find, it very depends on the protocol. Anyway, if we take the speed divided by our number of packets divided by 8 bits, we will have something like 32 bytes maximum. And so 32 bytes maximum per one message. But actually, if we open source code, and the ExpressLRS is open source, so we always can go and look inside how it works, how it made. So we go ExpressLRS, GitHub, src, lib, ota, oth, and we can see that standard packet size it's 8. So we have only 8 bytes. Is it big or not? Let's check. Imagine the one message from remote control to the drone. And the message is simple. Dear drone, the weather is nice today, so let's go flying. Please set the flight mode to the horizon and turn on your engines. Then please set the throttle value about 37.5, but keep roll and pitch values around 0 because I don't want to move aside. With love, your Petro K. Yeah, good message, but apparently we find out that If we save it as a text file, we will see that it is 281 bytes, not 8 bytes. So let's try to shrink it. If we reduce it to this text, we will get 83 bytes. And if we sacrifice description and just pass the values, even then we have 32 bytes, but not 8 bytes. So how does ExpressLRS team made all this goes inside of this? But to answer this question, let's first check how any electronics store any data. So the storage of any data, any message, it's like a copybook page where each cell it's one digit. And we used to know that we can store digits from 0 to 9. It's decimal system, but any electronics use binary system, so it can store in one cell only 0 or 1. And this means that in one cell we can store data like one switch, off, on, 0, 1, true, false. So one cell of information, it's one bit, which can store two values, 0 or 1. And if we would like to encode more values like 3, 4, 5, then how many bits does it need? And the physics mathematics is simple. You know, if we would like to add +1 to the maximum 9, then we need to reset this digit to 0 and add +1 to the next one. The same in binary. So we had, for example, 01, we adds 1, so we reset this to 0 and increase the next one. So in binary, 1, 0 actually equals 2 from decimal. So don't put too a lot of attention on it, just use this lookup table. For example, the digit 3 is encoded 1, 1, the digit 4 encoded 1, 0, 0, the digit 10 encoded like 1, 0, 1, 0, and so on, so on. And the digit 255 can be encoded with 8 bits. And here we are, the 8 bits, it's actually 1 byte. So 1 byte, it is some standard amount of data stored by electronics or passed by any message. So we can pass digits from 0 to 255. And for example, if we need to pass higher digits, we will need more bits. And for example, we can use 10 bits to transfer digits from 0 to about 1000. So why do we need all this? So just get back to our switch. We can encode position 1 to 0, 0, another position to 0, 1, and position to 1, 0. So we need, for 3 position switch, we need 2 bits. Well, we can use even 4 position switch anyway. But if we want to encode more accurate, for example, gimbal, it's not 4 position switch. It has lots of positions, so we can split it to about 1000 of levels and encode it with 10 bits. So again, to transfer position of gimbal enough accurate, we will need 10 bits. And now let's get back to our 8 bytes and imagine that this 8 bytes is actually this net. 1 byte is 8 bits, so 8 bits, 8 bytes, it will be 64 bits. So all this is 64 bits. And if we open source code, we will find description of this data. So if you know syntax of the C language, you can actually transfer these values to this digit, to this net. But let's go one by one. First, we pass type of packet and use 2 bits, and we use some CRC high and low. And actually we've got this 2 and 6, and we've got this. Let's check one by one which is which. First, type. If we also open the source code somewhere here, we will see that there may be 4 different types of packets. It can be RC data, remote control data. It's actually what your gimbals and switch and buttons values are. So we can send a message that will contain all information about your control. It may be a sync packet. It is the first message that is used when we establish connection. I will tell more about it a bit later. Telemetry message, also another type of message. It is a back message. It's something that's sent not from RC to drone, but from drone back to remote control. I will also tell about it a bit later. And finally, we can have MSP data, and it is very universal thing. If we go deeper and have some Google, we will find that MSP is the main communication protocol used by Betaflight. Surprise! And if we open Betaflight configurator, we see this MSP. So what does it mean? MSP is used, for example, to communicate between your PC and the flight controller. So you can see this port is used for USB connection, and it is using MSP protocol used for connect of the computer to your flight controller. Or for example, you may enable MSP to control your digital video transponder and send the digital OSD data. MSP display port, not really. Well, the digital one is also using MSP. So it means that we can transfer not only the values of our gimbals, but actually almost any data that we would like. For sure, there are more limitations that will not allow us to play so much and send anything we like, but in theory, by ELRS protocol, we can send some commands like turn on some functionality or even emulate work with flight controller instead of USB connection. I will tell about it a bit later. And getting back to this, we've got type, 2 bits used to transfer the type of the message, and then CRC. What is CRC? And in general, CRC it's control checksum, and it is the mechanism that use it for validation of your data. Let's say you cry, go on, and someone on another side of the earth just hear, hold on, go on, hold on. It sounds very similar, but the values is opposite. So how can we know that we have heard correct command? And the answer is a checksum. You can encode each letter. So for example, each letter has its number, then you can summarize, make the sum and take part of the sum. Yes, CRC works a bit more difficult, but in general the principle is a bit similar. So you can send this, let's say 36, and when you receive data you also can calculate this checksum and compare. So we send go on 36, and unexpectedly we received hold on with 36. We check that hold on checksum will be 44, which is not equal, and this means that we have made an error when receiving message. So Getting back to this packet, these bits, are used to ensure that the rest of information is passed correctly. Okay, let's go deeper. Next, OTA channels 4 by 10 bits. 10 bits, yes, unexpectedly, this is 10 bits. So we have this amount of data, this part of message used to transfer 4 gimbal values: throttle, aileron, pitch, roll, whatever. So we use this to transfer the accurate value of each gimbal. And if we go to the ExpressLRS site, we can see that in some table we've got description that in hybrid or wide mode, sticks 1, 2, 3, 4 channels used for stick has a normal range. Normal range is 10 bit or 1024 positions mapped to some values. So we use it for gimbals. Okay, next. Something about channel map. Actually, we can tell that the first one will be roll, the second will be pitch, or the third will be throttle and yaw, or we can tell that the first will be throttle, then roll, pitch and yaw. And probably you've heard these terms before: aether or tire. It is the channel map, and it's actually the order of which stick we assign to which part of the message. So both of your remote controller and drone should have the same configuration. On remote controller you should set one of these, let's say aether, and on the drone you also should set the same aether. If you set different aether on one and tire on another, you will have just mess of these sticks. The sticks will be mixed up. So keep it in mind. And next, the last part of data, it is channel 4 used only 1 bit and switches for used 7 bits. Here it is 1 bit. And if we read more details, channel 5, which is AUX1, it is 2 position arm switch. This why we have seen that the AUX1 always have minimum or maximum value, just because we always send it with only 1 bit, so we send it in this way, only on or off. Okay, and the next is 7 bits used for everything else. Surprise, but how can we put all our lots of switches and buttons or whatever to 7 bits? Let's check the website. Okay, 6, 7 and so on. We have 6 position for hybrid, or we've got 36 or 64 or 128 position, but we've got this RR, and RR means round robin. What does it mean? Easily, it means that we don't send the all information in one message. We have number of message, and let's say in message first we send all gimbals, we send arm value, and we send, let's say, AUX2 and AUX3 only. Then with the next message we send all gimbals, arm value, and the next set of AUX. I'm not sure about this order, which channels are sent. The ELRS experts will correct me, but anyway, principle is this. For hybrid we send few aux channel in message 1, few aux channel in message 2, and so on, so on. This why, yeah, and getting back, so for hybrid mode it is only 6 position. So we use less data, for example, only 3 bits or part of these bits, so we can transfer 2 aux at once or even 3 aux at once in one message. And you remember in the beginning in the test when we used hybrid, it was working rather fast, but it was jumping from one of these 6-point position. And if we go to wide mode, we use whole 7 bits to transfer only one aux. So in message 1 we send aux 1, in message 2 we send aux 3, and so on. And obviously here we need maybe 3 or 4 messages, so less messages to transfer all aux channels rather than in wide mode. In wide mode we will need much more messages to send each aux. This why we have some delay between different aux values. It will be sent more accurate because more bits are used to transfer in more accurate way, but we will need more messages, so until we send each of message we will have some delay. So this tells us why all that behavior differences. And now a bit more about another types of the packets and the packet sequence. Imagine that you just turn everything on, and as I told before, the first thing that we send, it is a sync packet. It actually does not carry all the values of the sticks, but it carries the parameters, the packet rate, the mode, wide or hybrid or any else mode. So it tells to the receiver in which configuration will we work. Then when the connection is established, we throw a number of remote control data messages and then receive back telemetry message. And by the way, you see there is a configuration telemetry ratio, which is 1 by something. It means how often will we receive telemetry. So in this example we have 1 telemetry per 4 RC data, so it will be 1 by 4. If we send telemetry less frequent, then we will have another value, so it's another one parameter that also is sent. And what is a telemetry? Telemetry is actually some information that is sent from drone, from ELRS module back to our remote control, and we can display it on the screen or whatever. And what message is? It is like RSSI or LQ, which is actually the health of the signal, or we can send the RX BT, which is the value of the battery on the drone, or GPS coordinates or whatever. So all this information may be transferred here and displayed here. And there is a bit small difference between types. There is a telemetry information that is generated by ELRS module. It's internal ELRS telemetry like LQ and RSSI. And there is a data that is generated by your drone like battery voltage or GPS. It is sent to the ELRS module, and only then it is also sent to the receiver, to the transmitter, yeah. And by the way, both of them can be turned off or disabled. So for example, if you turn on all your system, if it works well, but you do not see the value of the battery in telemetry, then probably in beta flight, in configuration of transmitter, it might be telemetry disabled. In this case we don't have this connection, and nor battery neither GPS will be sent here and will not go there. So you will need to go to configuration and enable the telemetry, then it will be sent. Or even the whole telemetry may be disabled in general, it is made in configuration of ELRS device. Sometimes it's needed, for example, for racing, when you do not want to spool to the air any extra data. So that's all about the messages side, and we've got time to answer the main question. And finally, as a result of all that was told before, the reason why ELRS 2 and ELRS 3 are not compatible. And the reason is very simple. There was a major change in data format, in packet format. There was added 10 bits support for all 16 channels. There was added duplication of the channels, actually new frequencies was added, so the difference in channel format makes these two versions incompatible. Okay, now I will tell you about binding phrase and how do ELRS protocol resolve collisions. As we all used to, when we have one remote and one drone, we usually press bind button on one, press bind button on another one, and get everything in. But what if we have a more difficult situation? For example, if we have one pilot who owns multiple drones and he would not like press binding button each time when he switch from drone to drone, then ExpressLRS provides us a pairing phrase functionality. This means that we can pre-configure remote and drones with specified pairing phrase, and the remote with a drone with equal pairing phrase will automatically sync up on boot up and will make a connection and will not try connect to devices with different pairing phrase. And one aspect, who turns on first, that one device catch a connection, and even if another drone is turned on later, it will not be picked up, but it will wait until this one will turn off. So who turns on first, this one pair gets connected. The pairing word can be configured when we flashing ELRS device or in Wi-Fi interface, web interface for ELRS 3 and upper, or for SPI ELRS in beta flight configurator, but I will tell you the difference about serial and SPI a bit later. Now, how does it works inside? The pairing phrase is converted to a set of digits. We apply MD5 algorithm to convert this phrase to unique numbers, and these numbers later used inside of the sync packet. Just to remind that ExpressLRS has a type synchronous packet that is sent when devices are turned on. So this information is passed from the radio to the drone to establish a connection. And as you can see, the UID is a part of this information. And if we go forward and we'll look at the handler of this sync packet, we can see that if it does not match, then we tell okay, it is not our connection. So we check UID 3, UID 4, and a bit more difficult check of UID 5. And here we've got, what we've got, it's model match. The model match, it's another term As you probably know, we can configure ELRS connection with model match check. It means that even in scope of one pairing phrase, we can configure devices to different models. So we can set device X, device Y, and switch control to one or another, or as usually used, we set 0 to control any. It gives us more flexibility, more variability. Okay, so we started looking inside of the source code and we can see more configurations. As you can see, we can configure rate, and here it is rate. We can configure telemetry ratio, here it is. We can configure switch mode that we was speaking about before, and it's configured here with this variable nonce. Don't know what does it mean. So all this information is actually passed in the sync packet. And what else I would like to tell? As you can see, part of UID is actually passed through the air and it is open, it's not encrypted. This means that binding phrase is not a password. It has no relationship to protection or data encryption or whatever. It is just collision resolve mechanism, nothing more. So be accurate and don't suppose that your connection is encrypted. It's still open. And what else do we see? We can see that some of this data, B2, B3 or whatever, is used for some seed, some fhss sequence. What is it? And this is anti-collision mechanism. So as you probably remember, when you flying racing, and if you fly multiple pilots, multiple drones, you should use different frequencies. For example, for analog racing, we have 8 channels, for example, R1, R2, R3. The same is with ExpressLRS. Inside of specified bandwidth, we use channel 1, channel 2, or channel 3, and each pair drone and remote using its frequency to not interference with each other. But for analog video we have defined the frequency manually, and for ExpressLRS we use frequency hopping spread spectrum. This is fhss. What does it mean? It means that after sync on the base frequency, we switch to some other frequencies and we change the frequency with some period of time. So we work on some pseudo-random frequency 1, then we switch to frequency 2, and if we have 2 remotes, and so we will use different sequence, or we hope that we use different sequence. So for example, one remote will go to F2, then to F1, another remote goes to F3, then F4. And we use some formula that defines actually the sequence of this switch, and this sequence depends on UID. So when you define the pairing word, you actually set one or another switch sequence. This reduces the probability that you will ever switch to one sequence and make a conflict. But still, there is a chance that you can pseudo-randomly switch to one sequence, and in this case you will lose part of your connection and you will have to go to sync and go to another sequences again. And there is a formula that defines the probability of losing packets if you fly together with your friend. So according to this formula, for example, for 8 pilots, the probability of collision is 17%, which corresponds to LTU, link quality, which is actually how many of packets are successfully transferred, is 100 minus 17 and 1, so it's approximately LQ82, which is rather good. And here is a table of correspondence, how many pilots, how much theoretical LQ. As you can see, 5 pilots it's LQ 90, 2 pilots it's 98, so almost no collision should happen. And for 20 pilots it's half 50-50, and for 40 pilots it goes to 0. So we cannot fly more than 40 pilots. This is the fact. Okay, and probably you have paid attention that when you flash in your ExpressLRS, you can switch the regulatory domain. And this information, the regulatory domains, it's actually the set of rules and the set of laws that controls the usage of open frequency. And for different countries it may differ. And for 2 and 4 GHz, usually all over the world we use domain, which is equals to set of rules. This name, and in, for example, Europe Union, we use more strict rules, which is CE2400, which may differ. For example, this one, Europe Union, also have more limitations on the power of usage and the rules of transmitter behavior, like LBT, listen before talk. So the rules might differ, and the algorithm that defines switch between frequencies in this mode also might differ. So the conclusion is, even if we flash drone with same bin phrase, same ELRS protocol version, but different domain, we still have a probability that it will not work together. So pay attention and use one domain for all your devices. That's all about domains. Time to speak about the hardware and the difference between serial and SPI ExpressLRS. So what we will start with? We will start with something that is equal for any type of ELRS. It is an antenna, surprise, and LoRa chip. It happens that the LoRa is some technology under patent. So there are not a lot of different chips that provide us LoRa modulation. Typically for ExpressLRS it is used SX1280, but there are some different options, just one of the typical. Then, next, for UART ELRS, we need some chip that will make a logic, that will form the actually data packets that will be transmitted or handle received data packets. It was decided to use ESP chip, typically, or some else chip. And the interesting fact that selected ESP chip usually has Wi-Fi and Bluetooth on board, which is a very good bonus. What does it give to us? We'll check a bit later. And now communication with flight controller, and here we've got actually serial, which is UART. So the communication between this chip and flight controller is made via serial interface that use CRSF protocol. Please do not mix up. CRSF protocol, it's something different than we looked at before. So the packets like data packets or telemetry or sync packet that was looked here in this video before, it's something that is formed by the logic chip and then received by air. And it is not equal to data received or transferred by this wire between flight controller and the chip. So this CRSF, it's surprise, it's Crossfire protocol. It was open, so it was reused for ELRS. It gives us a benefit that we can take a drone with a crossfire module, unsolder it and solder ELRS, and it will just work. And if I'm not mistaken, the first version of ExpressLRS was actually copy-pasted from the old crossfire devices. I may be mistaken, please correct me if I'm wrong. So it was one of the reasons of using CRSF. Next, we have the option of ELRS module integrated to the flight controller, so you can see the difference. Here we've got ELRS device separate, and here we've got ELRS device integrated. So we just take the chip, one chip, take another chip, and just put it on the flight controller PCB. But from point of view of physics, of configuration, it is the same serial crossfire protocol device. So from point of view of configuration in Betaflight, it's no difference. And finally we came to SPI. What if we want to make it this schema more simple or more cheap or more lightweight? We can get rid of the logic chip. Why? Because we can put all the logic into the flight controller chip. Because it can. And here we've got finally SPI. Why SPI? Because the interface of LoRa chip is SPI. So we simply connect SPI to the flight controller chip and put all algorithms of these packets forming and packets analyzing from here to actually flight controller. So we put it to the Betaflight software. So here is the difference. UART and SPI. Yeah, SPI looks more simple, but UART has number of preferences. So what is the preference that we got with UART? First, it's Bluetooth. We can use ELRS module with Bluetooth to connect our remote control directly to the computer by Bluetooth and use in-flight simulators. Or we can use Wi-Fi to communicate between computer and flight controller configurations, and from Betaflight configurator communicate without any wires. There are other benefits, and actually there are a number of other benefits. For example, we have functionality of backpack, which allow us from radio to control our Googles, which is rather interesting. And the flashing methods. If we want to update ELRS software for UART, we should update the software of this chip, of the ESP microcontroller. And if we want to update ELRS, we should update the whole Betaflight software, which is rather big. So as you can see, when we are updating UART ELRS serial, we just use ExpressLRS to generate and update the flash of this only guy. And here we take the Betaflight configurator and update the whole software. And please keep a note that as we have the logic integrated into the Betaflight software, then we should remember that ExpressLRS version 2 was used for Betaflight 4.3 and earlier. And if you want to use ELRS 3, then you have to flash with Betaflight 4.4 or later. Actually, there is some tricks that there are some tricks that allow you to use ELRS 2 on Betaflight new, but I'm not sure about it. So this is the fact that we have to deal with when we use SPI ExpressLRS. Okay, getting into the details of the serial flashing method. It allows us very big variability. We can use Bluetooth we can use Wi-Fi to flash, we can use the serial connection to flash, whatever we can use to flash. If you follow recommendation of ELRS team and use Wi-Fi, then in ExpressLRS configurator we bin the binary, then we switch ELRS device to Wi-Fi mode, so we turn it on and wait for 1 minute, and it switches to Wi-Fi and opens Wi-Fi connection point that we can open and connect to get this web interface and put this binary file here, and it will be flashed. And one of the benefits that if you don't have Wi-Fi at your PC, then you can copy this binary file to your mobile phone that probably has Wi-Fi and connect to this web interface from your mobile phone. Okay, the other version. If we use Betaflight pass-through, what does it mean? It means that your computer connects to flight controller via typical USB connection, like when we connect to Betaflight. So ExpressLRS communicate to flight controller and ask it, please convert to a bridge. Then flight controller chip converts to a bridge and gives access from computer to the actually chip via serial interface, and we continue flashing. Or if we don't have flight controller, or if we have bricked the ELRS chip, we can use such dongle and flash via UART. It's another one option, so lots of option of flashing this guy. And as I told, the SPI gives us only one variant with Betaflight update. And the last thing that I would like to tell, it's about wiring. Receivers or internal transmitters has 4 wires connection. It's actually power, ground, and serial transceive and receive, which connects cross versa. So RX on ELRS chip goes to TX on flight controller and vice versa. At the same time, if you connect external module, it has only 3 wires, which is actually power, ground, and signal data. That is, use 1 wire in half duplex mode, and works 50-50. Sometimes part of the time it works to transceive data, part time it used to receive data, and in total it uses only 1 wire, so just one aspect. That's all about wiring. So many words, so many letters, and all this just about how this talks to this. So, concluding all that was already told, there are a lot of information, and I have not covered any kind of topics like LoRa scripts or features of ExpressLRS or how to install the configurator or whatever, because this information is already covered in internet. And on the other hand, I suppose that there might be some mistakes and errors in my information, because it was difficult to gather all information, not enough information. So if you have any more details, please welcome to comments. I would be really happy to see your feedback. So thank you and see you next time.